We're going to graph the system of inequalities. So we've got the first one is y is greater than or equal to negative x minus 4. On this one, I just decided to let my x and y axis just take the middle here, because it seemed like there's plenty of room to deal with these coordinates that they gave us. So this one says I basically want to start at negative 4. So that's down here. 1, 2, 3, 4. And then I have a slope of negative 1, which means I'm going to fall 1 and run 1. So the line's going to go this direction. So it's going to kind of go along these coordinates along in here, slope of negative 1. So I'm going to go ahead and draw that line in. It's a solid line because of the or equals. So that line's in there. One thing I want to do here before I go any further is I just want to kind of check and make sure I've done this right. A line with a slope of that's negative should always fall as we go left to right. Okay? If this line's rising as we're going left to right, it has a positive slope. So that's one just quick check to make sure I didn't make a really dumb mistake, and kind of rule that out, and then go on from there. It does have an intercept at negative 4, so that's all good. I'm going to check shading here. If I test the point 0, 0, and I put 0, 0 in for this equation, inequality, I'll get 0 is greater than or equal to negative 0 minus 4, which is the same as 0 is greater than or equal to negative 4. 0 is greater than every negative number, so that's true. So the true side's this side where the 0, 0 is. So I'm going to be shading the upper side of this line. Off to the next line. It's also an or equal, so it's going to be a solid line. It has the intercept at negative 2, so I'm going to go down to negative 2, put a dot. And then it has a slope of 1/2, so I'm going to rise 1 and run 2. And I'll do that another time just so I have another point to graph through. So that graph takes off through these points. Notice how it rises as we go from left to right because it's got a positive slope. So the line's going to be a rising line. It's got a positive slope. Let's go ahead and check its shading. If I put in 0, 0 for it, I've got 0 is less than or equal to 1/2 times 0 minus 2. That simplifies to 0 is less than or equal to negative 2. Again, 0 is greater than every negative number, so this is actually false. It's not true that 0 is less than negative 2. It's greater than negative 2, so we're going to shade the other side. I don't want to shade the 0, 0 side. I'm going to shade the other side. So the overlap of the shading for these two graphs is going to be this region down in here. And that's all they asked us to do was just graph these. So we've done that. We're done. Any questions here? Number 2 is a linear programming concept. We're given a bunch of information. We're asked to do a couple things. Let's see what we've got here. We're doing a bake sale. We need at most 25 cakes. We're doing some vanilla and some chocolate. We cannot have more than 10 chocolate cakes. We're supposed to do a couple things. We're supposed to write and graph a system of inequalities. That's all we're supposed to do is write the system and graph it. So there's basically two things we're doing. Write a system and graph it. So let's see if we can write this system first. I know there's some vanilla cakes. I know there's some chocolate cakes. I just let x equal the number of vanilla cakes because it's the first thing I saw. And I let y equal the number of chocolate cakes because that's the next thing that they talked about. Now, some of you guys did it the other way around. You let the x be the chocolate and the y be the vanilla. That's okay. The graph just comes out kind of 90 degrees, sort of flipped over, like y equals x is what it looks like. But I did both on the key so I could check for both ways. At most 25 cakes. Well, if some of them are vanilla and some of them are chocolate, that means when I add them together, I can't have more than 25. Agreed? So if I take the x vanilla cakes plus the y chocolate cakes and add them together, that has to be less than or equal to 25 total cakes. At most means I cannot have more than. So I've got to get that set up. It says I cannot have more than 10 chocolate cakes. That means that I have to have less than or equal to 10 chocolate cakes. Agreed? So y is going to be less than or equal to 10. Cannot have more than 10 chocolate cakes. The only other constraint I can see is I can't have a negative number of cakes. So the number of vanilla cakes is greater than or equal to 0, and the number of chocolate cakes is greater than or equal to 0. So at this point, I've done one of the things they wanted me to do, which is to write a system of inequalities. And now I just have to go graph that system. That's the other half. Since x is greater than or equal to 0 and y is greater than or equal to 0, that'll tie me to the first quadrant. So I just let the x-axis be the bottom of the graph paper and the y-axis be the left side of the graph paper that way. I can use all the graph paper for my graph. I went by 5s along the graph, so I have 5, 10, 15, 20, 25, and then all the way out here would be 50. 5's this direction, 5, 10, 15, 20, 25, and all the way out here would be 50. The first equation, when x is 0, y is 25, gives me a point. When y is 0, x is 25, gives me a point. I can go ahead and draw that line. It's a solid line because of the or equals here. The equation y is less than or equal to 0 or 10. I just have to go up to 10 on the y-axis and draw a line because that's where y is 10, so everything's below that. You're going to be shading below the x plus y is less than or equal to 25 and below the y is less than or equal to 10. So my shading overlap is going to be this trapezoid down here in the bottom. And that's all they asked us to do. They didn't ask us to find corners. They didn't ask us to find the maximum or minimum. They just asked us to do this much of a linear programming problem, so that's where we'll stop. Any questions here? And in this section, we're supposed to do some matrix addition, subtraction, multiplication, and division kinds of things. So number 5, all we're supposed to do is solve for x. In order to solve for x, I'm actually going to be subtracting this matrix to the other side, right? Just algebraically. When I subtract that matrix to the other side, x equals this 2 by 2 matrix minus this one. Well, I know if I subtract a 2 by 2 from a 2 by 2, I'm going to get a 2 by 2. So negative 5 minus a negative 1 is just negative 4. 4 minus a negative 7 is 11. 8 minus 1 is 7. And 5 minus 5 is 0. That one's done. So we're just looking to do some matrix addition, subtraction, whatever. Number 6 is a little more work. I'm going to have to triple everything in this matrix and then subtract it to the other side, but then I've also got this negative 1 to deal with. So this is going to take a couple steps. I know it's going to get subtracted over here, but it's going to get tripled before it gets here, so let's triple it on the way. 3 times 2 is 6. 3 times negative 8 is negative 24. 3 times negative 4 is negative 12. And 3 times 2 is 6. So that just took care of this 3. Now let's subtract it all. 4 minus a negative 6 is a negative 2. Negative 6 minus a negative 24 is an 18. 2 minus a negative 12 is a 14. And negative 8 minus 6 is a negative 14. The only thing I haven't dealt with is the fact that this all equals negative x now. So I've got to multiply everything by negative 1. So when I multiply that all by negative 1, I'm going to get my answer matrix. I'm going to get 2, negative 18, negative 14, and positive 14. So that one took quite a few steps to do, but we're done. On number 7, we want to multiply everything by negative 4. So this is a little smaller problem. I mean, it's a bigger matrix, but it's a smaller problem because it's only one step. I just have to multiply everything by negative 4. So negative 4 times 7 is negative 28. Negative 4 times negative 4 is 16. Negative 4 times 0 is 0. That's the first row. The next row, negative 4 times negative 3 is 12. Negative 4 times 0 is 0. Negative 4 times 5 is negative 20. That's the second row. And the third row, negative 4 times 6, negative 24. Negative 4 times 2, negative 8. And finally, negative 4 times 1 is negative 4. That's all they asked us to do on that one. And the last one there, number 8, is just multiplying two matrices, and if we follow the rule for that, we'll be okay. A 2 by 2 times a 2 by 2 should result in a 2 by 2. This is a row 1, column 1, so we're going to multiply row 1 times column 1. We've got negative 7 times the 8 plus negative 1 times 8. That turns out to be negative 64. Next element here is row 1, column 2. So we have row 1 times column 2. Negative 7 times 3 plus negative 1 times negative 3. That turns out to be negative 18. And the bottom row, when we do this multiplication, is negative 32 and negative 18. Any questions here? This one, we're going to flip this across the x-axis. If you think about what happens to a point when you flip it across the x-axis, the x value stays the same, right? It goes down here. The x value stays the same. It's the same distance over. But the y value goes negative. So we're just going to keep the x values the same of all these things and change the sign of the y values. And that's done. That last one at the bottom there is a 360 degree rotation. If I rotate something 360 degrees, where does it end up? Where it started. So the question is actually the answer right there. Any questions on those last two?